Desk Ladyada.
Hey everybody, welcome to a Sunday smorgasbord desk of Ladyada. We've been busy here at my desk. I got a whole bunch of stuff done this weekend. It's Chinese New Year, so happy Year of the Ox to anyone who celebrates. I'm sure Chinatown here in New York was awesome, but we're staying home, staying safe. But let's kick it off. We've got a couple things to show off today. I thought let's start with a STEMMA Sunday. Do you want to try going to my computer? Okay, so this is a really interesting chip. I thought once in a while I'd show off some like hidden secret, treasures from the chip vault. So this is a hot swappable I2C buffer with stuck bus recovery. Okay, it's got a long name. So this, folks maybe saw in the store, we have the ISO 1540. It's a bus isolator for I2C, so you can have totally separated, like isolated electrically bus and power. This is like kind of like a friend to that. It's not isolated, but what it does is, if you've ever had the experience, if you have a board and you're like hot plugging in chips like STEMMA QT boards, you might notice that if you aren't careful, of course, it like can jitter the clock and data lines, or even like the power lines a little bit, and it can cause your bus to go into like a weird state where like the number of clocks isn't like 8 or 9, and like it gets all weirded out and freaky. If you haven't experienced that, well, congratulations, but it's one of the things I don't like so much about I2C. But what this chip does, which is cool, is it separates the clock and data lines on both sides, and it like pre-charges them, and also like makes sure that like when you plug in the in, it doesn't, or sorry, the out, it doesn't affect the input until it's like, ready, and then it will connect the two when it's like the bus is, both sides are fully charged, and there's no activity going on. So this is a cool chip. So I did design a breakout for this. Let's see, where is it? I think it's under level shifters, even though I know technically it's not a level shifter. So let's open this up. Just one second. Okay, so I kind of like copied a little bit of the ISO 1540 design. It's got the separation, but I think this will be really handy, especially when, look, anyone here who's had this experience knows how debilitating it is when like your clock lines get screwed up. Okay, so that's the STEMMA Sunday. So now I thought let's spend the rest of the time before the great search on the overhead, and let's show some cool stuff here. So first up, okay, hold on. Okay, great. So this is the QT Py 2040. I showed this on the show, and I also went by Scott's stream and showed it off. But this is exactly what you think it is. This is a STEMMA QT board with the STEMMA QT connector, 2 buttons, power supply, little micro NeoPixel right there. And then on the bottom, the RP2040 crystal, a bunch more passives, flash chip, probably 4 megabytes, maybe 16 megabytes, I gotta decide. And all the, I know it's castellated, but maybe people can make a cutout of the board. I don't know. Anyways, I think this could be kind of cool. Bill Binko asked us to make a little jumper for the power pin here, and I did. So hopefully this can be used for USB host as well. So yeah, what's really nice is that it's got all the same pin out and pin names as the STEMMA QT, the SMD21. But of course, it's this awesomely powerful RP2040. So I just got back the Rev A PCBs like kind of like Monday or Tuesday, put together, showed it off on Wednesday, and I'm doing my final tests on this, but I'm pretty much ready to send out this board, and I think people will dig it, so that's cool. So that's another STEMMA Sunday. Thank you, QT Py. All right, and then next up, I want to do a little mailbag. Who doesn't love mailbag? I got this in the mail today. So this is the most adorable hot plate ever. It's so cute. So this is by Miniware, and I gotta tell you, like this is like the Apple of like nerdy engineer shit. Like they're so cool. Like they made this awesome. Let's see if there's an. I don't even remember if there's an on-off switch or how this turns on. kind of mystified always. Hold on. Maybe you plug it in. You touch it. I don't know, maybe the battery has to be charged. But they make like these little smart tweezers that I love, and they're also well known for their like smart screwdriver and like the TS80 soldering iron. So they love to put little OLEDs and stuff and make like super smart little tools. And this is what I love about this, is I want to do like hot plate at home, but like you don't want to have a hot plate that could like burn down your house, right? Like every Amazon review for like a hot plate is like, there's a bunch of 5-star, like, this is a great hot plate, and the other half are like 1-star, burnt down my house, okay? Not good. So this mini hot plate preheater, well, hopefully I could be able to actually do some like a hot air, not just preheat for like hot air rework, but actually maybe like solder paste and like melt a PCB. And so this is it. Hold on. So the packaging is like Apple-esque too. Okay, so you've got this. I mean, it's like ridiculous, right? Like, look how cute this thing is. So this is the hot plate itself. So there's this like big metal thing, and there's like a heating element, I guess, in here. And then for the adapter, it's a USB-C, and then, like, you can't really read the text, but it says 20 volts, 3.5 amps. This is like a really chunky power supply. It also comes with like a little Euro adapter. And then, of course, we'll need a really thick cable, so thankfully, looks like they included it. I just have to figure out how to open this. Ah! Okay, oh yeah, they got these really nice silicone cables. All right, so, I mean, do people want me to plug this in? Phil, anyone saying plug it in?
Well, yeah, I mean.
Okay. All right, so
it's already been dubbed the QT Py of hot plates.
well, I mean, so the reason I brought the QT Py out was because I actually wanted to see, like, would I be able to like rework this? I was like, oh, it's so cute. Can't take it anymore. All right, so let me try plugging this in. So hold on, give me a second. I need to unplug this.
You might want to swing the camera around a little bit more forward and then tilt it at an angle. So
yeah, I'll do that. All right, so I'm gonna because I want to like show you the little OLED.
Yeah, so then move it forward a little bit.
Oh yeah, look at that.
And then
this is like the Snyder cut.
Yeah.
Okay, is that in focus?
It's good enough.
It's good enough.
Yeah.
Okay. All right, so then I'm gonna plug this in.
Someone suggested you could fry a small egg on it.
A very tiny egg. All right.
Those little quail eggs sometimes.
Yeah. All right. So heating, setting. Oh, they even tell you what to do. Okay, so press this button. All right, it's starting to heat up. Yeah, and it tells you it's like 9 volts. Oh my God, it's like getting really warm. Yeah. Oh my God, it's like hot. All right, well, I'm going to put this board on just to see what happens.
Well, what's going to happen?
I don't know, the solder might melt. I want to see how hot it gets, basically. This is so cute. Oh, look, there's like a little NeoPixel that changed color.
I guess after it hits a certain temperature.
Yeah.
So it was green, now it's blue.
Yeah. Now it's like a bluish, whitish color. This thing is so cool. So I wanted to stock this in the shop. So I got one to test for myself. So it has to hit 240 degrees for this to be able to like, melt.
How does this actually work?
I have no idea.
Like why? Well, how is it getting so hot? Like what's going on?
I mean, the current is going into like basically a resistor. It's definitely an electrical heating element. It's basically just like the hot plate on your 3D printer, right? The thing that keeps it warm when you want to do, like, I think ABS plastic requires it. So this has embedded in this top plate, which of course I totally can't touch anymore, is like a little resistor going through it that's like 0.01 ohms. Red. So yeah, because it's hot. All right, so I'm gonna grab my tweezers real fast. And let's look. It's not quite melting, but I can smell, it's starting to smell like molten solder a little bit. And let's see. No? I'm willing to sacrifice this board a little bit. All right, so it's at 230. Oh yeah, oh my God, it's like actually melting. Look, I could remove a component.
You did it.
Replace it. Wow. Okay, so this is cool. So what's great about
Well,
this?
it's hot.
It's really hot, and so I'm going to turn this off. And I'll very carefully, of course, move it to red. But what's cool is this is perfect for me to make one STEMMA QT board at a time. This is like, or like a little quail egg. So much success. I'm actually going to unplug it because I actually don't know if this is like.
Yeah, I don't know if it matters if you let it go through its own cool down process or
Well,
not.
it's actually heating up. I don't trust it. So I just unplugged it, which is another nice thing. So I'm going to very, very, very carefully move it
Will
away.
a feather fit on that?
No, a feather is this big. So it's not good for a feather, but it's
Yeah.
very good for like a STEMMA QT. I basically got these just so I can make STEMMA QT boards at home.
To be
without-
fair, the Trinket, the Gemma, and the QT Py, those are popular boards.
Yeah. I don't want to grab any because it's very hot, so I don't want to show
I can see
anything.
someone getting one of these and running boards with OshPark, getting
Yeah.
components, and it's like my first reflow.
Yeah, you saw I just lifted
Yeah.
this board. So this is perfect for, maybe I'll try to get a little angle so you can see the, not. Sorry, I'm moving.
Yeah, I've said it before, like, if you're just getting started with electronics now, good for you, because everything's available. Everything's available and everything's possible.
Yeah, so
Where
now I know that
before it
this
was a lot harder.
works. So now you know what I do. So people are like, how do you know when something is good to stock in the Adafruit shop? You just saw the process that I go through. Like I get one, and I actually put it through its paces. Like if it's a soldering iron, I'll actually solder a kit together. If it's a hot plate like this, or hot air, I'll actually use it to rework a board. So this is good to go. I love it. Oh my God, it's so cute. Whoa. Nope. Luckily, it was just cold enough it didn't damage itself. So, sweet. I'm going to put this away safely. I'll deal with it later. Nice. Okay, so that's approved. All right, so let's move on. So that was Mailbag. Cool beans. Good work, Minware. I love their stuff. Minware, they're just like my favorite. Okay, so, sorry, cleanup time. So next up, I want to talk about a new pull request that just came in to CircuitPython. Might be interesting for people who are CircuitPython users with the RP2040. So, sorry, there's a lot going on here. Okay, so this over here, this is my RP2040 feather. Hold on. No, come on. Okay, this is my RP2040 feather, and this is the Feather M4 RGB LED Matrix feather wing. So you plug it in, and boom, I'm running the CircuitPython example on RP2040, thanks to a pull request by Jeffler and Phil B, who worked on this last week. Bringing, I saw people using RGB matrices with the Pico in the CSDK, but check it, we now have it in CircuitPython. I had a couple little bugs with it that I wanted to have them take a look at, but it does pretty much work. And what's cool is you can do text and animations and colors, and you don't have to compile anything in C, and it works. It even has tiling now. I only have one of these matrices. This is a 32 by 64 LED matrix, and I only have one here at the desk of Ladyada. But we have support for tiling them. You can make a big square or a big sign if you wanted to. And the RP2040 has tons of RAM, so it's perfect for that use case, because it can, these displays use a lot of RAM because you have to write the whole display constantly. We're not using PIO for this, in case people are asking, hey, are you using PIO? Not yet, but we hope to add it. We want to just get it working first and optimize it later. Okay, so while I was doing this, I was like, man, I wonder what the Deska Ladyada is going to be, or the Great Search, because we did this IDC cable before, and then I realized, oh, you know what? Terminal blocks. People are always wondering how and what kind of terminal blocks we get. And so,
where in the world is that part I need? The Great Search with DigiKey.
All right, the Great Search is brought to you by DigiKey and Adafruit. This is where Ladyada uses her powers of engineering to show you how to search for things on the DigiKey site. Thanks, DigiKey, for making this happen.
All right, do you want to go into the overhead again real fast, and I'll show what it is I'm gonna show. So this is an RGB matrix, and these matrices draw a lot of current. You know, they need 2 to 4 amps, and so they have these big power connectors, these big Molex connectors on the back for power. This is data only. You couldn't pass power over this, no way, because it's amps. You need these big cables. And on the ends, what I do for this little driver board that the RGB Matrix data plugs into is I have the power coming in through terminal blocks. Screw terminal blocks. So you see here hold on, that you use a screwdriver, which of course maybe I'll put together in a second. You use a common screwdriver, usually a flathead, but a Phillips also for some. And you can loosen it to remove the cables. And you can see there's like these holes that wires can go into. And we use these a lot. We use these on our motor drivers. So these are terminal blocks. And then you'll want to measure your terminal block pitch, which is the distance center to center. So these are, I'll get this. These are 3.5 millimeter. Sometimes they're spec'd in inches, sometimes in millimeters. These are 3.5 millimeter. This one here is more. This is 5.08, also known as 0.2 inch pitch. And we use it a lot whenever we need to pass a lot of current or control a lot of current or have semi-permanent connections, like on our Cricut board. We have a solenoid connected and we have a motor connected. These are things that are drawing, an amp or more. You want to have a solid connection. Yeah, you could use JSTs, but a terminal block, any wire will work, right? And why not? That's great. So let's show how to get terminal blocks on the DigiKey site. So let's go to the computer. Okay, thank you. All right, so we're at DigiKey, and here's the good news. Sometimes I'm like, ooh, there's like a trick to getting the terminal blocks. The terminal blocks searched, the component, figuring out the name of the component to search for it. But in this case, terminal blocks is really easy. You just type in terminal block, super easy. And let me zoom it in a little bit. Okay, so there's a lot. And the terminal blocks are used like everywhere. There's like punch down type, and there's like accessories, and there's like, you can tell that there's power distribution ones, there's ones that are used for like fuse boxes. But we want the basic wire to board kind, because it's a wire, screw it in, and then attaches it to the board. It's a great easy way of making any wire connect to a board. Okay. So next up, let's, as usual, apply only active items. Just make it easy. And I want only RoHS compliant ones. And, I only want ones that are in stock right now. Okay, great. So the first thing is, well, first off, you can always go down and look at some of like the cool, weird, like this is an angled one. Like you can see it's like not 90 degrees. There's ones with little push buttons instead of screws. So like the screw part is optional. They're all terminal blocks, but there's different ways of doing it. This one was also a little springy type. This one is a screw type, but it's also, you see this angled. I'm not a huge fan of the angled types, but like I see why people like them, right? So let's first count how many we need, like positions, because actually that's the most important thing first. For this one, the feather wing for the RGB matrix, we need 2 pins. So let's search for that. So here's something also when you're searching for positions. So terminal blocks, it's not unusual to have them only available in 2 and 3 pin sizes, because you can slide them together and connect them like they're little like little snappy Lego-y type things. I'm using the word Lego-y completely against how the trademark is supposed to be used, but that's okay. We covered that in the last Ask Engineer. So you may, if you need something like a 5-pin block or like a 21-pin block, you might actually have to you might have to get a bunch of 3-pin blocks and you slide them together. And learn from my experience, every brand has a slightly different notch for sliding. You can't mix and match them. So you should pick one brand, one maker, and you stick to it because you can't mix and match them. But believe me, I've learned my lesson with that. I once got a mix of the 2-pin from one, 3-pin from the other, and it was a mess. Number of levels. So how many tiers you have? Basically, you have header and you have dual header and triple header. Same deal. How deep do you want the connections? In our case, we only want one because we just want a 1x2 header connector, terminal block connector. Okay, next up, the orientation, like that angle, right? How do you want it? Well, I want plain, I think horizontal with board, right? Sticking out this way. It's parallel to the board, not perpendicular, but again, they got these cool angles. Got to hit them angles. Check those out. So now we go down to these pictures and we're like, okay, yeah, this is what we're looking for, right? This looks right. There's like tons of different ones. Like this one is kind of a cute angle here. This one they're photographed a little bit differently, but that's basically what I'm looking for. Next up, through hole or surface mount. Let's go to the pitch. So you'll see that there's a lot of different pitches. In general, although not 100%, the pitch will determine the max amount of current and the min and max wire size. If you have very small wires, you'll need smaller pitches, but that also means you're carrying less current. So on one hand, the pitch determines like the physical size, but the physical size and the pitch also correlate with the amount of current. So you have to make sure, which sounds like, okay, like true is true and false is false. Sure. If you have a current requirement, in my cases, my current limit is like 2 to 4 amps, which is not that much. But if you have a current limit, you might want to search by current. If you're like, look, I know that my robot needs 50 amps, you'd want to search by current for your connector that goes from the... Sorry, yes, there's a question.
I know this was covered in part of searching for connectors, but what is the most accurate way to measure pitch on center?
Ooh, good question. We actually have a guide on it. So how about I take a second and give you a tour of my caliper tutorial. Good job, Ladyada, from a while ago. And I think measuring connector pitch, okay? I got it, okay? Check out that guide. It'll tell you how to do it. There you go. And so use that technique. Try to get me, but I gotcha. Okay, so, right. Current, if current's important to you, use that to determine the pitch. However, in my case, I have size requirements, and so I'm going to do it by the other way around. So whichever is most important to you. If you're voltage and current bound, use those to search. But for me, I'm not, because it's like, this is 5 volts, 4 amps. It's not that much. It's like, yeah, it's like barely even going to make a difference. Only like the most tiniest pitches would not be able to carry that current. All right, so another thing to watch out for. There's 5 and there's 508. Yeah, I know. But in general, the 508s, I found that the 3.5s and the 508s are the most common sizes. Those are the ones that we use the most. 5 is when we have like a significant amount of current, usually like 4 amps. 3.5 is like 1 amp or 2 amp is what we use it for. Although, again, these can carry a lot more. Okay. So now you'll see, yeah, like if you have a 508 millimeter pitch terminal block, the minimum is 8 amps. And the minimum voltage is 300 volts. So, like, this isn't a big deal. It's only if you are working with something that's, again, like 40, 50 amps. All right, and then wire gauges. Again, the connector, the way that the wire pokes in and you use a screwdriver to connect it, it'll affect your wire gauges. For me, it's not a big deal. I just tell people to add some solder, but if it's important to you, good time to check it out. There are surface mount ones. Let's see if I can load this 360. Oh, sorry. So you can see like the terminals here are surface mount type. That's not what I'm going to use. Terminal blocks, you can get them surface mount, but they really work best as through hole. So I'll get through hole. All right, so great. So now we're actually down to like 73 products. That said, they're all going to be very similar, right? There's like, everyone makes, there's like punchy type, and there's like screw type this, and there's green, and there's blue. The color doesn't matter. The color is totally your stylistic thing. So given that I have a lot of choices, I'm going to do what I always do, which is sort by price. And then I don't necessarily pick the cheapest thing because there's only 24 in stock. Scary. I don't like that. I'm going to pick the one that has 27,000 in stock. All right? That's like my heuristic. If they have 27,000 in stock now, I'm feeling pretty confident that this is a highly stocked item. I will not have problems getting this in the future. And remember, once you get one model of terminal block, if you want to fit them together and make larger ones, you have to stick to one brand. So, previous Ladyada did write a guide about connector pitch, did not think a lot about the realization that the little nubbins on the side are different for each brand. So here you can see the 360, so you can see that little notch here, and then it matches with this notch here. So you can see, zoom in. So you see that this notch, you can kind of see this little black triangle. They slide in together to make longer ones, and that's how you make more. And then the only other thing, if you care, do you want Phillips or flathead? Some people care. I actually personally prefer flathead for these. So this is why I like this particular one from Onshore Tech. But yeah, there's also ones that are Phillips head that people like as well. All right, and that's the great search. Now we found a wonderful, inexpensive terminal block for our RGB Matrix Featherwing.
Where in the world is that part I need? The great search with DigiKey.
Okay.
All right, that's it.
All right. Any other last questions?
Is the 5.0 millimeter some freedom of unit conversion?
Unit conversion. Well, it's 5.08 millimeter pitch. That's the pitch between the contacts. So if you're matching to your PCB, you'll just have to make sure that you use like a footprint that has the pads, the through-hole pads, 5.08 millimeter, otherwise known as 0.2 inches apart.
Are there screw terminal blocks for PCBs where you can screw by hand, like the ones in audio speakers?
Oh, like with thumb screws? I bet there are. Didn't cover it in this great search, but maybe we will in the future. Thumb screws is a popular thing. I'm sure there's easy ones. I will say that some people like the push connect type, although I find them to be tough to use. They're very firm, but they do exist. There's ones that don't require special tools.
Okay.
Okay, cool.
And that's it for tonight. Special thanks to everyone who watched and asked questions. We're here every single week, Desk of Ladyada, around Lady 8 o'clock.
It's like a necklace, like a very hot jewelry.
Yeah, careful.
Yeah, it's no longer hot.
And thanks for supporting the company. We are still a woman-owned manufacturing company in the USA. As weird as that is, we're still doing this.
Yeah.
So your orders keep it going, so please pick up something native for Adafruit.com.
Yes, thank you. That supports us and keeps us doing this thing, which we love to do.
Yep.
All right, thanks everybody. Have a great week.